tend to display. Oh,
Sorry.
no worries. These like human-generated behaviors tend to display a characteristic set of statistical properties. So they take these two ideas, and for this study, they go into quantifying whether these statistical properties that have been shown in many human behaviors are also present when children play freely, and whether these properties could have anything to do with cognitive development. So that's the framework that we are gonna be situating the study. Yeah, just I've prepared for like the study is very thorough and there are a lot of slides, and I know that we love having questions, but maybe if they are not super key, or like let's not try to like get lost into the details, because otherwise I don't think that we will have enough time to cover everything. But obviously feel free to interrupt if you have something. But yeah. So before we move on, they explain what are these statistical properties that we see in human generated behaviors. So the first one is that the temporal structure often has periods of repetitions of high frequency event types and periods of more rare events. So researchers who study how humans sample information have argued that these periods of repetition combined with these periods of more like exploratory behaviors reflect two opposing human tendencies. One is the exploitation of what is known, and then the other one is the exploration of the novel. So these two tendencies have kind of like been linked to curiosity-based or predictive learning, and the idea is that learners repeatedly sample from the same source as long as they are learning something new, reducing the prediction error, and then move on to explore something new when the prediction error is low.
Can I just, sorry, Marta, that there's a degree to which I think, there are other phenomena, other explanations that could explain that same finding though, right? So if we look at, Gio's paper on vocalizations and arousal, yeah, or I'm just working on a paper with Nigel Yuka in Finland that I was just sending to Katie about face looking. So face looking is also bursty. So if we've never run it, but if we look at times when the babies look up to the mum during a face-to-face interaction, yeah, it's bursty in the same way that these types of things are bursty, yeah. And vocalizations, it could just be that when I'm above a certain threshold of arousal, yeah, I'm more likely to do a vocalization, yeah. And arousal has autocorrelation, yeah. So that when I'm above a certain threshold of arousal, I'm more likely to a series of vocalizations because it takes time for me to go back down, yeah. Similarly for face looking, if I'm in a state of negative affect, yeah, I'm more likely to do face looking because I'm seeking, comfort from my parent, and affect has autocorrelation. So that's another explanation for why you get these patterns of bursty behavior. Similarly, exploration, yeah, I'm more likely to shift from one object to another if I'm in a high state of excitement, yeah, and that's also got autocorrelation. So it's not actually proven, this explanation for why we get these bursty patterns of exploration.
No, it's not proven, but it's a potential explanation, right? Like the same that you are mentioning. It's a bit like reductionist to put everything on the arousal also, isn't it?
Yeah. And also, I'm just saying there's more than one possible explanation for this phenomenon. It's not.
Their introduction.
So what?
Like there are multiple explanations to why would this be. I'm just like, obviously in the introduction you frame it in a way that it's like presents a story that could make sense to the reader, and that then it but yeah, no, I take your point that there could be other things explaining why do we get repetitions and like periods of repetition and periods of exploration, and this is obviously just one read. But yeah, like another of the properties, as Sam said, is that these periods of repetitions are bursty, meaning that they occur in clusters of repetitions that reoccur over some delays. So it's not all like a repetition until the prediction error goes to 0, but repetition, then moving on to something else, and then going back to that first thing. So and again, this is just one explanation, but researchers working on this property, of this bursty property, consider that it's this like shifting between repetitions and explorations what creates an optimal practice for learning, and it's what like facilitates what benefits learning. Then another main property is that temporal patterns are characterized by a skewed frequency distribution in which a few type of behaviors or events are very frequent, but most of the events are very infrequent. So that's another one. And then finally, these statistics show an overall pattern that can be summarized in a small word network in most of the events are only a few steps away from each other. So a relatively small number of transitions connect all the events in the time series. So we have that the temporal structure has periods of repetitions of high frequency event types and periods of more rare events, that repetitions of high frequency items are bursty, that the distribution is skewed, and that everything presents in a can be summarized in a small word network. So the question now is, what could it mean for cognitive development if these statistics that characterized a lot of the human-generated behavior time series are also found in periods where toddlers explore different toys. So the idea that the authors suggest is that the study of narratives might offer a possible answer to this question. So whether it's conversations or stories, these are a type of human-generated time series that follow the statistical patterns that we presented. So researchers in the field of this like study of narratives have thought a lot about the implication of these statistics in terms of how they help convey coherent information. No? So the authors of the paper take this framework, not because play follows the formal structure of a conversation, but because maybe the function of these statistics might be applicable to non-linguistic experience, in the sense that it could also be, in the sense that these statistics could be the reason helping convey coherent information, if that makes sense. So the study of narratives, just briefly, tell us that coherent narratives are characterized by a few high-frequency topics that occur in close-in-time repetitions, but that are also returned to over longer delays, and that these temporal patterns are believed to connect all the ideas in the narrative into a coherent whole. So hopefully everything makes sense as I go with the presentation, but if there is something unclear, please ask. But using their...
Sorry, Martin, can I just say one thing? Which is also, and don't get me wrong, this is one of my favorite papers ever. I love this paper, but it's also worth thinking about another explanation, how much you would also got the same explanation if you just had a pile of toys in a toy room, yeah, and you just set up a random walk algorithm, yeah, to just transition at random from one toy to another, yeah, and you'd only have to have two elements in that random walk algorithm, I think, to recreate all four of these features. Yeah. One is I have some kind of slow varying feature of, what I was saying earlier, how excited I am or something like that, which means I'm more likely to transition from one thing to another when I'm more excited, which gives autocorrelation to my transitions. And then I've got the physical location of the objects in the playroom. Yeah. So the physical objects and the location of the objects in the playroom would drive the frequency. Yeah. So I spend more time on the objects that are close to me. Yeah. And then it would also drive the structured transitions because I'm more likely to jump from one object to another object that's completely close to one another. Yeah. So and the burstiness is already explained, and the repetition and exploration is already explained. So basically, all you need is two factors. Yeah. The fact that objects have a physical position relative to me, and the fact that there's some slow varying thing that determines how much I just transition to explain all four of these features. So like that Linda Smith's really into this way of thinking. So, she wouldn't at all be cross about thinking like that. Just like what is the simplest? Is there a simpler possible explanation for these four phenomena that she's talking about?
But then isn't it what they try to disentangle with by creating the permuted data?
Maybe actually, let's talk about that when you get to it. Maybe.
That's what I thought, because essentially they took the distribution of the events of interest, so the frequency of all the events, and they shuffled them. So essentially the frequency at which the events are presented stays the same, but they break the time, the timings, so they put them at random. And yet they still find that the observed data is different than the perceived data, which would defeat the point of proximity, but also show that even if they are both skewed in terms of frequency, what we observe is showing these statistical properties more, if that makes sense.
Very possible. Let's talk about that when we get to it.
Yeah.
What do you want to say?
No, I was just going to say that. Well, I was just thinking that because I was thinking about the permutation procedure, but then I'm not really sure about the random walk stuff. How that is, I was just going to ask how that's different to the permutation, basically.
Well, I can't remember the details of the permutation. Let's talk about that when we get to it.
Yeah.
Marta, sorry, just quickly, on the same point for say C, it would also be affected by the way that you categorize things to study them. When we're talking about that paper that Katie presented, that was looking at the entropy between maternal behaviors, and we were talking about that problem of the entropy that you get is going to be affected by how widely or tightly you classify or categorize. So also here, if those few behaviors that you're saying occur a lot, if you chunked that first bar into 3, then distribution is going to be completely different.
Yeah.
I don't quite follow that point. I was making a similar point when you talk about the kinder.
They selected 3 different behaviors in that case, and all 3 different behaviors showed exactly the same. But yeah, it is true that it depends on how you break down behavior, which is essentially a very subjective choice. Yeah.
I mean, oh, sorry.
No, go.
On that point, Gio, maybe I'm being dumb, but since they're ranking it on the x-axis by frequency, I kind of would expect there's almost no way that you couldn't get something that looks like a log normal distribution, right? So how you chunk it shouldn't make a difference if you're ranking by frequency. Am I missing something big there? I feel like I must be.
But then if there's no way that you can't get a log normal distribution, does that mean that it is saying something meaningful about the data?
No, you don't It doesn't, I don't think it follows.
But maybe it was more about the differences, no, Gio? Like
Yeah.
that there is less of a difference between, let's say, the first behavior and the sixth behavior in terms of frequency. Yeah. Anyway,
the-
maybe we can. Sorry.
I was just saying with these, it's not like the behavior that, yeah, sorry, I'm not sure if I was following before, but then in this situation, it's specifically to do with like object sampling. So
Yeah.
if that affects what you're saying, Geo, that it's not necessarily like behaviors that they're looking for in terms of difficulty in classifying that, but it's like specifically to do with what objects they're going for. But yeah, I'm sorry, I'm not sure if I was. I'm not
Okay,
sure I was
okay.
being-
That's less subjective then. Okay.
No, but in other human behaviors, I take your point. I think, yeah, it's always gonna be a bit subjective. But yeah. Moving on. So, topic, comment, structure. So yeah, so using the terms of these narrative studies, they characterize dialogues or stories as having a topic comment structure. So where topics are high frequency items that are the given information, and comments are low frequency and they provide new information. So informative stories share new details while mixing them with the main topics that come up more often, if that makes sense. So what the study suggests is that the function of these statistics identified by theorists of narratives might be the same in learning for human-generated non-linguistic experience, and that it could potentially offer an answer to what it could mean for cognitive development if these statistical properties were also shown during the exploration. So this is the larger theoretical idea motivating their research, which I thought it was quite interesting. Their main goals were to provide an integrated understanding of the statistics, and that is because while the statistics are well recognized, they have often been studied independently, so there is kind of a need for some integration. To examine the degree to which they characterize the everyday experience of infant and children, and finally to explore the relevance of these statistics to cognitive development. So the study was very simple. They asked parents to play with their toddlers for 10 minutes in a room where there were 32 toys displayed in a random way. The parents were told that researchers were interested in toddler exploration play, and so they invited them to encourage their toddlers to engage with the toys. And the mean age of the toddlers was 21 months. Yeah, and I thought that this was interesting. We set the duration of the play session at 10 minutes because pilot studies indicated that this was the maximum period for continually engaged play by toddlers with a parent. I don't know, in the MRC project they're doing 20 minutes and it seems to work fine, but maybe it would be interesting to see whether there are differences between the first half and the second half. I don't know.
Marta,
Yeah.
did the objects always have the same position in space
No, it
for
was
the
all
child?
random. So, and here they dedicated a paragraph in explaining that the positioning of these toys, the way they were distributed on the floor was random, that they had, I think, 5 testers, and that every tester put them differently. So there was no specific instructions on how to distribute the toys. Yeah, they say we use this approach to limit any obvious or repeated organizing principle and to increase the I cannot say this word, generalizability of our findings to everyday contexts in which the spatial distribution of the toys in playrooms is uncontrolled and highly variable. So essentially, no, they must have had their researchers putting them as they wanted. Yeah. The aim was to quantify the statistical properties of sample toys from a toddler perspective. So they put a head camera and a microphone on the toddlers, and they analyzed that data. And the camera that they used was this one. So I thought that maybe if in the lab in the future we are doing something similar with FreeToy, we could maybe take a look at it because it's very small. And then they coded the data. That was also interesting. They coded the data in 5-second windows. So they say this was chosen based on prior research that directly compared 5 seconds and 1 second sampling rates of parent and infant behavior during play, and found that the sampling rate did not affect the overall temporal dynamics. So I thought about you, Emily, because maybe that's something that we want to do with the FNIRS, which could potentially speed up the coding. Yeah. And then the behaviors that they code were as Tom said, the act of selecting a toy. So they coded for infant handling a toy, parent handling a toy, and parent talking about a toy. And they did the coding manually. So they used DataView for toy handling, and they had some manual transcriptions of the parent talk. Yeah. Next. Yeah, so that's just an example of the data structure. So yeah, what is it important here? That yeah, so because the window is 5 seconds, multiple selection events could have the same timestamp. So for example, bucket, hippo, and hippo are all in the timestamp n. And then if a unique toy selection act goes, so bridges 2 consecutive 5-second segments, they code it twice. And I think that's that's important here. And they code it for toy, who, the act, and the timestamp. So within 89% of the 5-second segments, at least one toy was selected by at least one of the 3 behaviors, which I thought it was really a lot. Parents and toddlers handled objects roughly equally. So that was good. The mean proportion of video segments with toy handling by toddlers was 86, and for parents was 70. So really a lot. And then parent talk reference at least one toy in 80% of all segments. So yeah, they engage really a lot with the toys, but turns out that the dyads not just broadly sample all the toys available, but instead they were quite selective with what toys they were playing with. So the number of unique toys handled by a toddler were 15.2 out of 32, and by parents 17.4. And then yeah, this selectivity was not due to all the dyads favoring the same specific toys, which was good. All the 32 toys were selected by at least one dyad for play, and 30 unique toys were among the top 5 most frequently selected toys for at least one dyad. So this shows that like the top 5 the top 5 favorite toys for one dyad was not necessarily the same as for the other dyad. So yeah.
Marta,
Yeah.
I actually can't remember this part about the paper, but so it's like it's often this is phrased in like just child curiosity, child generated events. But for instance, like in our coding for Jupyter pieces, like we wouldn't count it as a child selection if the mum had pointed to it or had said to the child to get it, because it's not actually their decision to sample, it's not their like intrinsically generated behavior. And so I can't remember what they did, if anything, to control for that.
Yeah, so that's a good point. So first they looked at the frequency distribution of all these toy selections. So you have toddler handling, parent handling, and parent talk. And then they ran some statistics on those distributions to see whether there were significant differences. And because there weren't significant differences, so for all selection acts, all participants, there's many times. Yeah, so there were no differences in the distribution, and they correlated for all participants. Then they decided to create this aggregate. So essentially, instead of working with 3 different types of selections, they just merge everything irrespective of who and irrespective of the specific behavior, based on those analyses showing that there are no differences in the way that those behaviors occur. Now, I had some questions, because the way they did this is that they created these frequency distributions at a dyad level, and they tested, like they ran a Wilkinson test and a Spearman-Rank correlation at a dyadic level. So my question, and they were like lucky, let's call it, enough that all the dyads showed like the same results, in the sense that there were no differences in the distribution, and that the behaviors were correlated. But when you do this, I was wondering, what do you do if like a dyad shows significant differences in the distribution, or like non-significant correlations? Then I was a bit puzzled as to how can you just do this analysis. How would you interpret the results? But yeah,
Yeah, that's something we always sweat over though. This is what I love about Linda Smith. She's just, you know, we spent ages sweating over how do you pull apart the influence of the baby from the influence of the mum. And, you know, if you can't reliably disentangle them, then you don't really know what you're talking about. But she's right. She's just like, it's just a different way of thinking about it. Like it's just the parents are adjusting their behavior depending on the child. So why not just view this whole thing of how they interact together as a unit as measuring learning? I think it's good, but she's really good at doing this. I was good at just thinking, okay, fuck, actually, maybe it doesn't matter. Can I just go back, Martin? Just go back to those probability distributions. So I'm just a bit confused by it. So the toys ordered by frequency, is it that there was one particular, even though they've said that they played with 30 different toys on average, is it that there was one particular, so is number one on the x-axis of all of those, is it one particular toy? So it's just for each dyad, they rank ordered the toys by the most frequent to the last. So okay, fine.
Yeah, they are not organized by the specific toy, but but by the highest frequency to the lowest frequency.
For that dyad.
Yeah. Yeah. Okay, so from now on they work with the aggregated count of selected toys. That was the main point here. So this is the final histogram after collapsing all the toy selection behaviors. and then they partition each toddler's experience time series of toy selections into 2 categories. So the 5 most frequently selected toys, which they called topic objects, versus all the other toys that they were called common objects. And then they ask whether the statistical properties that we observe in many other human-generated behaviors also characterize the time series of parent-infant play.
This is oh, sorry.
No,
This is
go.
kind of a dumb question, probably, but why 5? Is that just arbitrary, or
I don't know.
this kind of feels like a big research degree of freedom, right? Like, if it didn't work out, you could pick 4 or 6.
Yeah.
I don't know.
I don't remember reading anything about why did they set the threshold at 5, actually. Other than maybe this is half of the distribution.
Yeah, that makes
Then
sense.
it's half, but then it would be half of the distribution for the grand average, but maybe not at a dyadic level. So I don't know, but that's a good question.
I guess even that is kicking the can down the road a little bit, because then you can say, well, why half? Maybe.
Yeah.
She always just picks. It's hard to do these types of analyses without making a few random decisions. I think she's not scared to do that. But if necessary, you can just run it saying that the findings aren't contingent on that. You just run it in the supplementary materials, run the same analysis with 4 and
Yeah,
6.
but I don't think they did.
Yeah, reviewers probably didn't care. Yeah. Fine.
They only think about this when it's our papers. Okay, so yeah, so they say that because some of the statistical properties that they are going to explore could just be explained by the quite skewed frequency distributions, they created some randomly permuted time series to then compare it against the observed data. So for each dyad, 10,000 random permutations of the observed time series were used to create the random baseline. And as I said before, they maintained the frequency distribution of the individual toy selections, but what they disrupted was the temporal properties. So the null hypothesis was that the measured statistics emerged slowly, so only from the observed frequencies of the selections of the different toys, and then the alternative hypothesis would be that no, there are some differences between the observed and the permuted.
So that doesn't quite address that point I made earlier, right? So the point I made earlier was their attention has got a physical position in space. Yeah. And that if the soldier is next to the caterpillar, then they're more likely to transition from the soldier to the caterpillar, yeah, than back. But the way they've done it is they've just looked at the total amount of time that they spend looking at the soldier, or the total number of times they look at the soldier, and the total number of times they look at the caterpillar across the whole diet, the whole interaction. Then they've shuffled them in time, but that doesn't control for the fact that they're more likely to transition from one to another just because they're next to one another.
Yeah. Yeah, providing they were moving, yes. Yeah. Yeah, they did mention this in the discussion. Now I don't remember what they end up concluding with. But yeah. Yeah. I don't know. Yeah. So first they go into exploring a continuity, which they define as the close in time repetitions from topics and comments. So to do so, they created cluster of selections of the same toy and measured the number of clusters and the number of segments with selections of the same toy. So essentially, they calculated, so every cluster would be 2 segments with the same toy, 2 consecutive segments with the same toy. So for example, the cluster Hippo here. So Hippo occurs here in time n, and then it happens again in time n+1, and then it happens again at n+2. So there would be, one, I don't know what I'm doing, one cluster, and the length of the cluster would be 3, if that makes sense, because it expands from n to n+1 to n+2. So they calculated these 2 properties. Yeah. So they found that briefly, there is a lot of detail here, probably unnecessary, but briefly, that the mean number of cluster was lower for the observed than randomly permuted data. So there were fewer clusters in the observed data, and that the mean rank length of the observed clusters were longer than the permuted baselines. So the clusters in the observed data, there are less clusters in the observed data, but these are longer. And then,
Oh, I'm really sorry. Do we have time for me to ask one more thing?
yeah, of course.
Sam, maybe you can tell me if I'm thinking wrongly about this, but couldn't this be explained by the fact that you've just disrupted the autocorrelation? In what, like, if the selection of toys is autocorrelated and you disrupt the autocorrelation, even if there's no mechanism there, even if it's just something to do with proximity or some kind of boring neuroscience thing, then yeah, you would expect there to be more clusters and the cluster run to be shorter without it saying anything interesting about toy selection.
Yeah, that's just the point I was saying about the spatial distribution when they've got something in their hand, when they're looking at the thing when it's physically, when their attention is physically on it in space. Yeah. That's all. It's just spatial autocorrelation. They only shift one by one. They would never do a big shift from one toy to another one on the other side of the room. They would shift to neighboring ones. The same point.
Yeah.
Did they explain why they haven't control for like the conditional probability also? I think like Tom, you had this
They
in one of your
do.
paper. They do?
Well, like, yeah, there's like network stuff coming up.
Okay, sorry. My bad.
But do they control for it?
Wait, so what do you mean, sorry?
As in, like what they've done is like, we call it like order zero sort of like shuffling. They just take the same probability as the toys and they shuffle accordingly. They create like the new distribution that has the same like probability of occurrences.
Yeah.
And then they test the length and whatever. And they found that it's more random. That was like expected, but why are they not shuffling it in a less destructive way by making sure that there's the same probability of transition between one toy to the next, as in they're keeping the first order transition probability. So like they're like counting if you go from the knight to the giraffe, this
Yeah.
number of time, and then you regenerate the whatever, like generated data, surrogate data, according to those transitional probabilities. What did they, Tom said that they might have done it later?
I'm not sure if they did that.
No, I don't think so.
Okay.
I don't think so. But that could have been interesting, no?
You know, like more stringent. I think Tom, you're doing this right for your Lego stuff, and the more I think you want to test order, like if you want to test the transition of transition, like over like 3 toys, then you need to control for the 2 toys order. I think.
Yeah.
If I'm doing that, 'cause what I'm doing is like comparing, like I'm not controlling the transitional probabilities, I'm just controlling the zero order probabilities. So like by doing the permutation of a network or a transitional probability, so like I'm looking, yeah, there's differences in transitional probabilities, but they're not controlled.
Okay.
But it's controlling for zero order to assess first order.
Okay. Yeah.
Yeah.
Sorry, zero order is from toy A to toy B, or that would be first order?
Wait, do you know?
the zero order is just how many they use. So it's the plot that you showed before.
Okay.
The first order is just like the Markov table with like
Okay.
you go from toy A to toy B, and second order
Okay.
would be if you go from toy A, then you go to toy A or to toy B.
Right. Yeah.
More and more context, but maybe you probably don't want to do it. Some of you can.
No, they didn't do that. They controlled for or zero order, right?
Okay, yeah. Yeah.
Okay. So next they looked at coherent discourse, which was categorized not just by the local continuity of topics, but also by returns to the main themes over longer delays. So for that they measured these, no, returns to previously selected toys. And they did this in a way where they broke the interaction in four quarters. So and they found and then so in dark blue is topics, and in lighter blue is comments, common objects and topic objects. So they found that topic objects appeared repeatedly throughout the play session, mixed with many and varied common objects, and that the proportion of topic selections, basically this. And then they looked at the data separately for the top 5 objects for each dyad. And they found that the selections of toy topics, so basically that all 5 topic objects were selected throughout each quartile. And so they said that because of these, we can say confidently that the pattern in this figure is not just due to selecting different topics. So basically, they are returning to the same toys throughout the interaction. It's not that for the first half they have 3 main topics, and then for the second half they have 2 other main topics. It's that the main topics stay consistently throughout the interactions. If that makes sense. Yeah. And then so next they wondered whether
So can I just say something? So
Yeah.
that Emily Phillips, so one of the things, so Emily's just doing a very similar paradigm to this, yeah. So that's something that's really interesting to look at. So Linda's saying this returning to play objects is something that's really important for learning for reasons Marta's building up to, yeah. But this is also heavily driven by the fact that they stay with those objects that are closer to them, yeah. So and that's why they keep on coming back to them, because the random walk and their things that are close to them. But the more your kids, the ADHD kids, are moving around the room, that will get in the way of that as a learning mechanism. Yeah. So if I've run over to the other side of the room, then I don't have these kind of repetition and frequency statistics that Linda Smith is saying are important for learning. So that's quite an important point, I think, essentially.
Yeah. I wonder whether, I don't know, I feel like we don't have many toys in our paradigm. I mean, I suppose it will still be. Yeah.
What do you mean you don't have any toys?
Well, we only have 5 toys. They've got a lot of toys in this paradigm, right?
Yeah, but yeah. It's still, you could still do the same analysis of how likely
you could,
turn to a toy that they were playing with earlier.
Yeah.
Yeah, although maybe breaking it down into topic and common objects is gonna be more tricky, because then you'd have like what, 2 topic objects versus 3 common objects. Probably the frequencies are less different than when you have 32 toys. But I also thought that maybe we could do something with the BO9, because it's quite interesting what they do. And I was thinking maybe like parents with a diagnosis of ADHD structure the play differently, or or infants. But yeah.
Yeah, I'm sure physically, how much they physically move around the room will
Yeah.
be a really important thing. Driving, do you get that pattern shown in B? Yeah,
Yeah.
it's because they're stationary that they keep on coming back to it. I'm sure that's the case.
But then if you assume that they are stationary, that goes against the point that you were making about proximity, right? So
It's
if
the same
we
point again.
but if we assume that they are stationary, the control analysis that they are doing by breaking down the temporal but keeping the frequency should be valid, because in
No,
reality,
physically they're stationary, but their gaze is moving around. Yeah, their attention is moving around. So their attention is moving around the room, but it will also, if you look at kids playing with a pile of toys, they never jump from playing with one toy that's over there to playing with another toy that's over there. They always transition from one toy to the one that's physically next to it. Yeah. But so that's one thing, which is they'll transition always between neighboring toys, but also they'll also keeping back to the ones that are physically closest to them. Yeah. So they'll reach out to one which is further away, but then the next one they reach to will probably be the one that's on the way to that toy, but nearer them.
yeah, I was just thinking that then it's fine. I had another thought. But yeah.
I mean, we could do this as a reanalysis. We could do that as a reanalysis. Just look at how movement messes this up. We could write to Linda and say, "Can we do this as a reanalysis?"
But maybe at that point it would make more sense to do what Pierre suggested, no? To control for the order one or one first order. Anyway, yes. Next, so that was not super related to their like study focus, but they also wondered whether the parent is the one responsible in creating these statistics shown. So it could be that the parent have a sense of like narratives or stories, and that they scaffold the toddler's play in that specific way. So to answer this question, they used cross recurrence quantification, which allow them to measure the leads and the lags in toddler and parent contributions to toy selection. So I thought it was quite similar to cross correlation, but it's slightly different. Yeah, but essentially, yeah, so cross correlation assumes stationary data and primarily detects linear relationships, whereas cross-recurrent quantification captures recurring patterns of structural change in time series and can handle non-linear and non-stationary data. So it determines all lags in time between all infant and parent acts on the same toy. So that was interesting. If the infant held the object in segment 1 and the parent selected the object in segment 2, 5, and 120, the lags are going to be 1, 2, 1, 5, and 120. So it's the way that you read the plot that I'm going to show next is slightly different than the cross correlation, so don't get confused like I did. But essentially, what the main findings were is that the peak was near 0, so referential acts to the same toy from the two partners more often occurred close in times. And then across both topic and common objects, there were on average more positive lags, so toddler preceding parent, than negative lags. And then the third main finding was that the mean lag for topic objects was smaller than for common objects, indicating that parents more quickly followed toddler interest to the same toy when it was when it was a topic toy, than when it was a common toy. So the whole take-home message from them for all these analyses is that parent and toddler toy selections are highly coordinated in time, but that it doesn't seem to be the case that the parent always leads and scaffolds the the structure of the toy. And here again, I wondered about the statistics, which I may have missed, but this is all they present. So they make comments based on the visualization rather than on like finding a positive cluster or a negative cluster or whatever. And maybe this is how it works for like cross recurrence quantification, but it was a bit surprising to me to present it like that. Yeah. Right. So in studies of human-generated behaviors more generally, skewed frequency distributions and bursts into small world networks in which the unique component events are integrated into a single network by relatively few connecting edges. So they wonder next whether toy selection during play have also this small world network structure. So to do that, they used graph theory analysis to kind of like ask whether the time series of toy selection within individual diets show these tied relational patterns. So the input to the network analysis consisted of pairs, co-occurring, or adjacent selections. So they entered everything. So here, for example, it would be bucket to hypo, bucket to hypo, hypo to hypo, and then that would just cover the segment 1, and then everything else again with the segment 2, and so on and so forth. I'm not pronouncing something correctly, right? Hypo.
Hippo.
Hippo.
It sounds good. Is that what you say in Spanish? What do you call it in Spanish?
What I said, hippopotamo.
Okay, it's definitely not a hypo. I never heard of it.
But why would you say hypo and spell it with an I? It's too
Yeah, when you said
confusing. Sorry, hypo.
Yeah, exactly. A hippopotamus which is about to fall asleep would be a hypopotamus.
Yeah, like what is she saying?
Yeah. Martha Thompson just saying, you've seen the time.
No. Okay. But okay, so they define the transitions for similar objects, but also for different objects. And what else is important? Yeah, the connections between these transitions were non-directional. So if you go from cow to dog or dog to cow, it doesn't matter, like the direction doesn't matter. And that they did the graph theory analysis for the observed data as well as for the permuted data. And then they dropped out. I know. And then they use this for measures of network structure to look at whether there were differences between the observed and the permuted data. So I will quickly go through the main results. So they look at edge strength, which is a measure of the frequency of individual transitions. So they showed that parents and toddlers often repeat the same toy selection, selecting the same toy in 2 adjacent segments or in the same segment more than in the permuted data. So the edge strength is greater in the observed data versus the permuted data, and it's also greater for topics versus comment objects. Sorry, that was for the same object, and then for different objects, they actually find the opposite pattern. So the strength of different object edges was significantly greater in the randomly permuted network compared to the observed network observed data. Then they also looked at the degree, which measured the number of unique edges connecting to a node. So the nodes in the observed network connect much more selectively than the random network. So the observed networks connect all platoids with fewer transitions than all the transitions possible, which is something that has been observed in like no, sorry. Different toys connected. Yeah.
Yeah, we get both of these.
And then the betweenness. So topic toys play a greater role in structuring the time series of toy selection that will be explained by. The betweenness, I don't. Yeah. So. Yeah, the topic toys are the ones that are selection of other toys disconnect those toys are the ones doing most of the transitions, if I understood correctly. And then the cluster coefficient, they showed that higher order size, yeah, the cluster coefficient was greater for the observed than the random networks, greater for topics and comments, and the interaction was reliable. So they said that this higher order structure systematically characterize the observed and not the random networks. But essentially, sorry, this was rushed. I had notes that I should have read, but essentially, yeah, they conclude the study saying that parent-toddler active play presents the statistical properties that are often shown in narratives, and that then therefore presents a learning environment characterized well, that it's well matched to know it's well matched for learning. And yes, that's that's it. Sorry, it was a bit rushed, the end.
No, that's fine. I think there's a chance actually I wrote to Linda Smith and said, yeah, but this all could be, all of those network analyses could be explained by that point that Pierre, was it Pierre, someone was saying about all it's just an autocorrelation. Yeah. The thing that I was saying too, that you shift between neighboring things. Yeah. But I think there's a chance that I wrote to Linda Smith and said that this could all just be explained by like a random walk. And she said, yeah, but it doesn't matter. It's still good for learning anyway. Yeah. She's very much into this. This is just a really dumb property of our environment. Like, she did the whole paper on babies who've got short hands, yeah, short arms. So when they hold an object, when they're looking at it, it makes it very visually salient, yeah, because it occupies almost all of their visual field. But she's like, yeah, obviously this is just because babies have got short arms, but it's still a useful thing for learning. So I think that's what was her point. Actually, I think it's coming back to me that that is the fact that they have a physical position relative to objects. That means they come back to certain ones over and over again, but that's still useful for learning. Is for an obvious reason, but it's still important.
Yeah, and I guess they could not come back at all.
They what?
They could also not come back at all, I suppose. Even if the objects are closer, they could. The distribution
but it
could also be different, no?
Yeah, but it's not that they're doing something in a way that's consciously useful for their learning. It's just this is a really dumb property of how we interact with stuff, yeah. But it's still important. But that makes the point about doing the same thing with kids who've got lots of mobility with ADHD. That makes that all the more important.
Yeah.
All right, we've got to go. Well done, Marta. Very, very nicely presented paper, Marta. Well done, thank you.
Yeah, especially the end.
All right then, we're late. See you later. Bye everyone.